We're going to start chapter 7 with a little bit of review. This should look familiar from some of our previous chapters. Let's talk about valence electrons again. Remember, they're the electrons that are responsible for the chemical properties of atoms, so they're pretty important in the world of chemistry. Remember, they're also the electrons in the outer energy level. They're the ones that are the S and P electrons in whatever the outer energy level of the atom you're dealing with. They represent the electrons in the highest occupied energy level, or the ones furthest away from the nucleus. They are not the core electrons. Core electrons are all the other electrons that are in the energy levels below the valence shell. Atoms in the same column have the same outer electron configuration, which means they also have the same number of valence electrons. The number of valence electrons are easily determined. It's the group number of the representative element. So if we're in group 1, you can see if you look at the electron configuration in the lower left-hand corner, they all end in 1. So group 1 all has 1 valence electron. Here's group 2. You can see the configuration numbers all end in 2. Now we need to skip 3 through 12 because they're not what we call group A elements or representative elements. We'll come back to them in a minute. If we skip to group 13, we can see that the last number all ends in 3. So just think 13, take away the 1 in front of the 13, and there's 3 valence electrons in every element in group 13. 14, of course, all has 4. Here's 15, 16, and 17. You get the idea. 15 has 5, 16 all have 6, 17 has 7. And then group 18. So helium only has 2. That's why it's above the table. It doesn't quite fit this trend. But it behaves like a noble gas, so that's why it belongs in this column. But everything else in 18 besides helium, you can see all end in 8. So group 18 generally have 8, except for helium, which has 2. Now, if we're looking at group B elements, or the transition metals, elements 3, or groups 3 through 12, we can't go by their group number. So you just need to look at the last number in the electron configuration. It's usually a 2 or a 1. So a way of showing and keeping track of valence electrons is the electron dot diagram, which we've talked about before. So to write them, all you need to do is write a symbol. Then you put 1 dot for each valence electron, and each element can at maximum only have 8 valence electrons. So you put them on the 4 corners. And remember, we don't pair them up until we have to, according to Hund's rule. We learned about that back in chapter 5. So if we were putting 8 valence electrons, we would do so like this. 1, 2, 3, 4. We spread them out. We didn't pair any electrons up because we had free spaces to put them. But now we're out of room, so we start pairing them up. 5, 6, 7, 8, like that. So let's do the electron dot diagram for nitrogen. So first we need to write the symbol for nitrogen. If you don't know it, you need to find it using table S in your reference table. But nitrogen is element number 7, so it has the symbol of N. Then you need to decide how many valence electron nitrogen has. So if you look at its configuration, you see the last number is 5. Or you'll notice that element 7 is in group 15. So all of 15 have 5. So we add 1 electron at a time to each side. And you can start anywhere. Doesn't matter. Just start somewhere and either go clockwise or counterclockwise. So there's 1, 2, 3, 4. Now I'm forced to pair them up because I've run out of room. And there's the 5th one. So remember, a valence electron is an electron in the outermost shell of an atom. And there's many ways to find this. You could look at the position on the table. It's a representative element, group A. You could look at the last number in the shell notation if it's a group B element, like a transition metal. Or if you had the electron configuration in SPDF notation, you could look at the total number of electrons that are in the outer S and P sublevels. We visually represent valence electrons with dot diagrams. To do that, we write the symbol in the middle and we surround it by dots, at most 8, to represent all the valence electrons that an element has. And always remember that the valence electrons don't pair up until they have to. In the next couple of videos, we're going to take this a little bit further and we're going to look at how these electron dot diagrams would look different with atoms that have gained or lost electrons, in other words, ions.